Hello, everyone, and welcome to today's session, Chip Antenna Design and Validation Services for Wireless Applications from Concept to Production. My name is David Zimmett. I'm the president of Orion Technologies, and we are Johanson's representatives in Canada since 2015. I'd like to introduce you to today's presenter, Manuel Carmona, Senior RF Product and Business Development Manager and Senior RF Engineer for Antennas and Integrated Passive Components. He holds a Master's in Electrical Engineering and RF Electromagnetics and has been at Johanson Technologies for 14 years. Hello, how are
Hello,
you?
I'm good.
Great.
Thank you. How you doing?
All right, thanks. So, folks, prior to beginning this session, we would like to ask you a couple of questions. And at the end of Manuel's presentation, we will have a Q&A, as well as Manuel showing some examples of some designs using, of course, Johanson antennas. And we would love to hear from you via chat and or video. You will also be able to download a couple of documents and white papers related to today's webinar topic. When the webinar is over, we would truly appreciate your feedback about this session and future webinars. So we're going to proceed with Manuel's presentation, and then we'll come back for Manuel's demo of some samples he has, of design samples he has, and then of course the Q&A.
Hello and welcome to Johanson Technologies Chip Antenna Design and Validation Services for Wireless Applications from Concept to Production. So Johanson Technology is partnered up with about 70-ish% of wireless semiconductor companies out there. These are just a few examples. And these, in order to have customers use and implement their chipsets, they release several reference designs, sometimes geared to a specific application like IoT, but others also use it for specific platforms or types of products that are specifically a particular protocol or wireless frequency. So these semiconductor companies, these chipset companies, will put out a myriad of different reference designs with different shapes and sizes, and depending, of course, of the frequency. But bottom line is they're just giving you pretty much a building block, a starting point to what eventually will be your product, the shape, size, and what I'm trying to do today is pretty much guide you through the steps of selecting, well, first of all, what chipset is best for you based on what stack or frequency is going to operate in, as well as what protocol is going to use for Bluetooth, either be Bluetooth, Wi-Fi, Zigbee, LoRa, and so on. So ultimately, whatever product you're designing for will use one of these so-called starting points, right? And then you'll have to eventually select what antenna technology will be best for your product in that shape, in that size, based on the form of the end product, including the encasement. How is it going to radiate or beam the actual radiation frequency and so on? So you will most likely edit the original layout file, either be in Gerber's, Allegro, Cadence, whatever file it comes with that reference design. You're going to shape and mold it to your to the but at least a proof of concept what your product might be in a prototype stage. So when it comes to thinking, okay, you'll be thinking, okay, what antenna do I have to choose? I have specific range requirements. Maybe you have a gain on DDI or DD gain ideas of how it should perform ultimately and installed, of course, in application. So we have a chip antenna selection guide. It starts with what frequency is going to operate in, and what the shape of the PCB is, and also on a more granular level will be if it's going to be mounted on a corner of your PCB, in the middle of your PCB, or if it's a circular PCB, is going to be mounted tangentially or in an angular way. So we have a guide that I'd like to show you here, and I will share the link with you. So under johanssontechnologies.com, you'll just go to products, antennas, and then in the left menu there, you're going to be a chip antenna selection guide. So this will ask you, of course, most of them are rectangular, but also circular and other shapes. And this guide can take you through the steps of ultimately which part number will be best for that shape and size. There's no exact way of going about it, because we do recommend sometimes more than one antenna part number for that frequency, for that size, and for that ultimate position that you have selected. But let's say you don't know how to start. So let me show you a little bit of what I mean. Let's say you actually don't know, even the guide is not quite what you're looking for, or is not something you could follow because it's a more complicated end product. Let's say a Bluetooth wearable, for example, an activity tracker. Um, you could send Johanson your layout files without any antenna mounted on it, just the bare initial layout file. And we can recommend specific geometric modifications and select a couple of antenna part numbers that'll be best for that shape, for that ground size, and for that, obviously, for that frequency. So you will be assigned a Johanson RF engineer who will take you through this initial process. There is another service we provide that if you may be applied, or will be applied and may be voided for certain opportunities, where we'll actually get not only your Gerber files, but also if you have any STEP or 3D CAD files of the encasement, battery placement, buttons, and so forth, that we can devise a model there in the bottom left and actually put our antenna electromagnetic model and simulate and actually predict what kind of efficiency and gain you will have on that recommended part number that we ultimately select. So now you have, this will be about 95% related to reality, meaning an actual measured result in an anechoic chamber. So now at this point, you have your model, you have the Gerber file where with our recommendations, then you just easily implement those geometrical modifications that we recommended. You have a part number, but now you have to, now you have to do a prototype. You will go in and do a small prototype run, and you send us the either mounted or unmounted antenna PCB. We recommend, or we actually require you to have all the components mounted, soldered, batteries connected, any USB connector near it. All that influences the final fine tuning of the antenna. All chip antennas need some sort of fine inductor, capacitor, or component tuning, and we provide that service to define those values. So how that works is we will actually measure right at the feet of the antenna, and right at the feet of the antenna, but before the the slots available that we will recommend. Usually, it's a shunt series shunt fashion of available slots to tune, and we will find the values, measure this on our one of our two anechoic chambers, and give you the actual measured antenna efficiency of the prototype, the assembled prototype. So this is pretty close to um, reality in application. We also have some phantoms, meaning some certain body parts that we can apply or attach these to if it's a wearable, or specific materials, if it's going to go up against a cement or wood or wet or in a water environment. We have different methods that we can put or subject your prototype to, and it will give you a 14-page report of what we found, obviously the gain, efficiency results, and very most importantly for you as what to put in your final BOM will be the part numbers that will be used to tune the antenna. I grabbed an example of a wearable. It's a Bluetooth wireless headset that ultimately needed a 4.7 nano Henry inductor in series and a 3.3 nano Henry inductor in shunt. And we also manufacture inductors and RF inductors and capacitors. So all you need to do is copy paste it to the BOM, put that on your schematic, and you should be good to go. Thank you very much, and I will take any questions you have at this point.
Okay, Manuel, why don't you show us some examples?
Okay, sure, no problem. So this is a physically typical 9-volt battery, but with a catch. It has a Wi-Fi chipset at the bottom. The original application for the Roost battery, which you can see on Amazon, is to convert dumb or older carbon monoxide detectors, and instead of putting a regular battery, you put this battery. And if it were to activate, because it has a Wi-Fi chipset, you'll get a notification on your phone. So the challenge was that there was absolutely no space for a complete metal clearance, right? Because you got the actual battery cell, and then you got the little the little Wi-Fi module there, and we were able to, with the process that we explained earlier, to test different antennas that let me see that the lighting is kind of bad, but
yeah, we can
there
see it.
you can see it. Okay, there's the let me grab a pen. The the antenna really rests. This is a ground mounted antenna, meaning that this antenna, this Wi-Fi antenna here, mounts completely on top of metal. But then we weren't really sure if the gain will be enough, the efficiency won't be enough, because this is going to go inside this carbon monoxide that connects to the Wi-Fi router of your home. So we ran a simulation, and it gave medium to low, but acceptable, because it's such a small ground plane, right? This is I forgot how many millimeters, but it's not that it's smaller than my thumb. So once we got an efficiency of around 40%, 38% with this Wi-Fi chip that is 2.4 only. It's just a very simple notification system that converts your carbon monoxide into smart connected carbon monoxide, instead of spending $300 on the Google products or what have you.
Right.
This battery is about $50, or actually now it's $35 now, and the results were great, were amazing. It just the connectivity was great, and it became a pretty successful product. This is about 3-4 years ago. Another example was a Zigbee connected smart LED bulb. So really you can't put any antennas where the LEDs are because of reflectivity and some other illumination techniques that I'm not quite an expert on. So we only had this half moon area filled with electronics to put an antenna on. So right here, there is a Johanson chip antenna right here.
Okay.
To the tip of that will connect to this microchip Atmel Zigbee chipset. And these are the kind of challenges that we love to solve. And the only way we can do that is you talking to us. And what kind of every application has a minimum gain or efficiency requirement. Even if you don't know exactly what kind of gain you really need, we can usually help you out in that and can somewhat approximate. Okay, you're gonna need at least 40%, 30%, or in high-end applications or high-performance applications, you need at least 80-something percent.
Right.
And we can get the CAD file of this, right? The step files of this from you or for your mechanical CAD guy, and all we do is we import the electromagnetic model of our antenna in the step file and actually do a pretty close to reality approximation of the simulation approximation to see what kind of gain you can. And most of the time you can solve it with a surface mount chip antenna, which is what we manufacture. And sometimes you don't. Sometimes we actually tell you, you're going to have to go venture into another antenna technology. So,
okay.
Yeah, that's just briefly what I wanted to say today.
All right, thanks. And by the way, folks, the majority of Johanson's antennas are available as eval boards, and these are basically an eval board with an SMA connector on one end, the antenna mounted on the board. There you go. And these are readily available for customers who are interested in testing, at least preliminary testing of a Johanson antenna. And Manuel also referred to, reference capacitor inductance values. Again, Johanson offers an array of demo kits which have either capacitors in a certain package size or a combination of capacitors and inductors. And again, these are readily available. Just contact your local Orion person. So that's about it. Let's go ahead and continue with the Q&A. So we actually have our first question. We have Chaim Lieberman. Go ahead.
So it's a big. Usually, when you post the antenna or recommend antenna, you have it a matching series, and it's kind of tricky. You're using a PCB with no elements, no nothing, and it's for you it's easy design. Usually, our design is much more complicated. Elements around and different layers and everything is different, right? So it's a challenge for us to find out the matching components. And unfortunately, you guys not posting how what is the guidance to find out matching components for antenna. If you can make it available, any tools for matching components, it will be much better, much easier for us.
Because of the subtleties, Chaim, because of the subtleties of matching methodology, and because we also manufacture inductors, RF inductors and capacitors, as well as these surface mount antennas, and we provide the matching and tuning and anechoic chamber services. Most of the time at no cost, by the way. This is not part of our business model that we provide RF services because we're a manufacturer first. We rather do that internally as opposed to putting white paper or an app node as to how to tune a chip antenna. We rather do a really good job on your design, unless you are in the RF antenna business. I guess that's also a possibility. Do you guys? Are you talking about do you struggle tuning?
Yes.
With specific antenna technologies like a chip antenna or
Chip antenna.
Printed antenna.
Yeah, we have it. We have product called beacon, Zigbee beacon, right? And I added to my design a chip antenna. I put initial values that you recommend in your data sheet, but later on I found out it's not even close. It's not even close. It's not matching
Right.
the performance.
It never is, right? And it's on the data sheet. Those are just the matching components of our eval, of our, the all eval boards will have an initial matching component, but there's an inductor there. But obviously, this is not, your product will be different. We get your product shipped to us, your prototype, and we can tune it for you and give you the values, the part numbers that we use to make it nice and centered and resonating at the intended frequency. We can do that for you, and sometimes at no cost, depending on the business case. And if it's a small or R&D project, we just charge $850. So it's that simple. We just evaluate the business case.
Okay, sounds good.
Yeah, we love to because the subtleties and also these are going to be your values in mass production, right? You want to make sure that whatever part numbers we give you, those are it. And it took us going back 15, 20 years ago, it took us a long time to dial the art, because as you know, RF is not quite an exact science especially in tuning, in RF tuning, because you'll have different, plastics. Even if you change the plastic material, plastic manufacturer, translucency and thickness, it'll change the value of the matching component. Right. And we usually we would love to do it for you. Where are you located, Haim?
Toronto area.
Perfect. If you can, we'll have Ed or David from
Anton
from Orion contact you. I don't know if you have Orion's contact information. We'll love to help you out.
Okay. Thank you.
Thank you.
No problem.
Sure. So Anton's question is, how about dual band management? Like, for example, 2.4 and 5 gigahertz. So we have many antenna part numbers that handle more than one band. We have sub-gigahertz, like 900 megahertz ISM and 2.4. And to answer Antoine's questions, yes, we have 3 antennas that do 2.4 and 5 gigahertz. They range in gain and size. We have a dual band antenna that is only 1.6 by 0.8 millimeters with a 5 by 8 millimeter effective area that is used in Wi-Fi modules, or in the case of a Ring doorbell camera that uses Wi-Fi, that has a really, really small usage area on the PCB and is very effective. We're currently developing a tri-band Wi-Fi antenna, because as many of you know, there's a Wi-Fi 6 protocol that is becoming more and more popular. So we'll have a 2.4, 5 gig, and 6 gigahertz antenna coming up in the fourth quarter. Now, to answer Farid's question, what is the range of permittivity for those ceramic antennas? Farid, have you referred to the loss tangent or the dielectric constant? We have about 5 different dielectric constants the ceramic dielectrics that we use to develop these antennas. They start at 9.8 and we go up to 30 with different loss tangents, because we take advantage of our proprietary ceramic technology to achieve very peculiar electromagnetic properties like detuning. So as you know, you put antennas next to high dielectric constant materials such as our body or water. The higher the dielectric constant of the antenna itself, it's less sensitive to detuning. So we will use a higher decay. And also usually our loss tangents are pretty low. We're low loss. That's why we can achieve pretty decent gain in a very small form factor.
Okay, Mr. Isaki Durai asked for us to share the link to those documents. So what I've done is I've provided you with the URL. If you look on the left-hand side, you will see a number of documents available, namely those 2 documents the antenna and chip antenna selection guide, as well as the antenna and characterization tuning services. Next question, Nikhil Vora. You see it, Manuel?
So yeah, you've used our antenna for LoRa 1 at 868, and used KitKat for antenna 50 ohm circuit. So your question is a 4-layer PCB recommended, or can you use a 2-layer PCB? That's a good question. Depending on the size of the PCB, meaning, so a lot of these antennas use a counterpoise resonating theory to actually resonate at the intended frequency. So your resonating frequency was at 868, and 2-layer boards is usually just good enough to have pretty decent gain at 868, but in some really small form factor scenarios, it's actually best to use a 4-layer PCB, because those inner layers act as you're expanding the electromagnetically speaking, is the antenna sees or counterpoises a larger ground. So sometimes a really, really small 2-layer PCB might not be enough to have nice, decent gain. So it all depends on what kind of gain you're trying to achieve on a 2-layer board. And we can actually, not predict, but maybe in case that we engage with you, simulate and see how the gain will change or will improve on a 4-layer board. And you can make a decision if the 2-layer board, obviously cheaper to manufacture, is good enough, or if the gain on a 4-layer is just so much better that it justifies using 4 layers. So I hope that answers your question.
Okay. Next question, Farid Mir Hosseini.
So Farid, do you have any documents for the 5 types of dielectric constants? These, we don't really share our internal proprietary material properties. If you were to want to design your own antennas using our material system, it is possible to do that. We just have to enter in a different service contract where we can release two of those 5 materials that we use for antennas that are available for other RF designers to use our material system to design your own antennas. So my contact information, if you can, David, you can confirm that will be available. You can contact me directly, and I can talk to you about that. So I hope that answers your question. And Nikhil, you're welcome.
No more questions, anyone? Okay. We're going to end the webinar, and we once again would truly appreciate your feedback about this session and future webinars. We thank you for attending, and we wish you a great day. Thank you, Manuel.
Thank you. Thank you for having me, David.
No problem.
Goodbye, everyone.